Okay, let's continue. Let's finish this lecture. So, if the likelihood ratio is a monotone function, so let's assume that this is some function of mu x, and which is this decreasing function of mu x, and this is depends on zeta 0 and zeta 1. But if this is decreasing function of mu x, then setting to less than k is equivalent to ux is greater than or equal to greater than 2, then certain constant cu which determined from the level alpha condition. And so so to prove this, we need to establish that so because this one does not depend on zeta 1, so it is MP, but you mean the step 1, right? Step 1. So because it does not depend on zeta 1. Okay, step 2. Depend on zeta 1, so it is UMP. So that proves this, the first one. So the first part is easy. To prove the second part, so the second part is it is also UMP for this hypothesis, right? Composite versus composite. In this case, we need to show that this is non-decreasing function, because we want to make sure that it is the level alpha, okay, satisfies the level alpha condition, which is maximum of the. So we want to show that this one is level alpha, but since we from this one we know that this one is from here, right? So all we have to show is that as long as this is non-decreasing function, then this condition will be satisfied. Okay, so how to show that? So that's where I kind of wasted my time in the lecture last time. So okay, so P C star, which is increasing, how to show that this is non-decreasing function of zeta. Well, consider any arbitrary, basically the claim is, okay, the claim is if C star any critical region is MP, most powerful, then or UMP, then sorry, should it be zeta 1 0. So this is alpha, right? So basically we want to show that zeta prime is greater than 2 prime. So what we want to show is so this is if is MP, okay? So if C star is MP, then it said the power, right? The power is greater than the size, significance level. Why? Why? Because if you consider, so what do you mean by MP for level alpha? Okay, so let's say size alpha. It's simple size alpha is same as level alpha. So size alpha. So that means it is power, right? The rejection power for is greater than for any C, such that P C prime is alpha, right? So one case for any, right? For all C such that, so for any level alpha test, C star has the maximum power because 2 prime is the alternative hypothesis. So if you consider C, one example is a trivial test that is reject with probability alpha. So if I don't care, so I don't care what the data comes. I just so that this test means I ignore data and just reject it with this probability. Then this one satisfies this, right? Satisfies the level alpha condition, and so that means this particular one has alpha. So this is alpha, right? Because regardless of the null hypothesis, parameter, it gives the probability of rejection is alpha. So that implies that C star should be most purpose greater than or equal. So alpha, right? This is alpha. So this is alpha, which is prime, is actually prime. So that means P star, PC star, theta is non-decreasing function. So that proves the second part. So that's how that finishes the proof. And then as I covered already in the class, the main message is that as long as you can find the as long as you can, if the likely ratio satisfies the monotone likely ratio property. So that means if you can find the UX such that the ratio is monotone increasing or monotone decreasing, then you can easily find the UMP test. So that's good news, and that is especially true for exponential family if P theta is an increasing function or a decreasing function. So here's an example. So in this one, this is exponential family, right? So that is something like this. So that is the exponential family. So UX is X, right? No, sorry, K, summation X. So UX is a summation Xi. So the critical region, UMP critical region is what? Summation Xi is greater than C, where C is determined. In this case, Actually, this one is a monotone. So this one is decreasing, right? In UL. I mean the likely ratio L theta 1, because I just use this one. So p theta, this is p theta. P theta is increasing function theta. So that directly applies to this condition. So determined from C star p given theta 1 alpha. So basically, what is the exponential distribution is a gamma distribution, so gamma 1, right? So actually 2 times xi given theta follows gamma and 2, which is the chi-square 2n. So we can use this chi-square distribution to determine C. Okay, so that C is C is what 2 over 1 chi-square alpha degree of 2. So this is the